Welcome everybody. Thank you for coming to our session on MLOps in Azure. My name is Anna Wykes. I am a Microsoft Data Platform MVP. I'm a principal consultant at a company called Advancing Analytics, and I specialise in data engineering and cloud. Essentially, I've been doing this a long time. I've been doing it for over 16 years. And I started off in software engineering. So essentially, I love coding, but I also love data. So essentially moved down the data engineering route, and then also data ops and essentially MLOps.
Okay. Hi everyone, I'm Tori Tompkins. I am a senior data scientist, also from Advancing Analytics. I have much less experience at 4 years, but I specialise in MLOps platforms.
Okay, so first things first, what is our agenda? What are we actually going to be covering? What are we going to do? So the first thing we're going to do is actually look at the why. Why MLOps? Why is it so important? And then we were going to look at the model lifecycle and which bits we actually need to care about. Then we'll start exploring architectures, and then we will move on to actual technology itself. So we'll look at the Azure AI portfolio, we'll look at DataBricks, and we will look at Fast API. And then we will look at actually deploying and monitoring a model end to end. So the why. So MLOps, you would initially think that MLOps is essentially just MLOps is just the same as DevOps, right? It's just machine learning DevOps. Well, that's not quite the case. It's not that simple. There's a lot more that goes into actually productionizing ML models. But in essence, we want to simplify the deployment of our ML models. We want to be able to monitor our ML models, and that is really key. And we need to be able to essentially monitor the life cycle of the models.
So like Anna said, it may seem at first that MLOps and is come from ML and DevOps, but it actually, and it does pull very heavily from the concepts of DevOps, but it actually incorporates a lot of data engineering. So the complication comes from where software code, when you deploy it, is relatively static. ML models aren't so static. They're constantly evolving. The data is constantly changing. So the complexity of this is what makes MLOps a completely new field.
Okay, so a lot of you out there may already know these statistics around how most big data projects actually fail, and it's really scary that we're all out there doing our data engineering, our data science, and a lot of those projects aren't actually making it into production. But realistically, this is the situation that we're in. So if we look here at this first statistic, productionization of models is the toughest problem in data science, and that was way back in 2014. And then 2017, 85% of big data projects fail. And then in 2019, 87% of data science projects never make it to production. Again, these are really scary statistics. And Gartner estimates that between 60 to 85% of big data projects will fail, and contends that only 20% of analytics insights will deliver their intended business outcomes through 2022. And for us, a big element of this is actually getting our models into production. The whole concept of MLOps and knowing the processes we need to go through essentially is what myself and Tori are going to cover with this session. Some of those core components and those core areas that you need to consider to actually get your model into production and actually get it and get monitored in a way that is efficient and that you feel in control.
So why is MLOps important? So MLOps is pretty critical to the scaling of your data platform. You want to get models up and running really quick. And with an MLOps lifecycle platform, you're geared up to make that happen. Trust is also a really big part. So if you've got data pipelines and DevOps pipelines to deploy your models, there's a much larger trust that your models are going to work in production. There's also better integration between teams. So MLOps platforms really helps with the integration between your ML engineers, your DevOps engineers, and your data science. You don't have to be one person maintaining the whole thing. It's a team job. It helps with compliance as well. So if you've got highly regulated sectors such as finance, you want to be confident that you're abiding by the laws that your models need to. So having a system in place and an MLOps platform in place will allow that to happen. And then the final one, and maybe the most important one, is that you're really reducing the risk and bias of your models. If your models aren't producing the right outputs and they're becoming inaccurate, your users are going to lose trust in them and therefore stop using them. So MLOps platforms are pretty vital to the success of your models. And they also reduce bias. So again, if you're in a highly compliant industry, you want to make sure that all your users are getting the same output. You don't want to discriminate against certain users. So MLOps platforms are super important for that. So what is the ML lifecycle? So the ML lifecycle is kind of what an ML platform is really based on. And these are 6 stages. So you start in your explore phase, and this is really like an experimental phase for your data scientists, and it's typically where your proof of concepts will end. You'll have an evaluate stage, and this evaluate stage is responsible for testing the model and making sure that you're getting the right accuracy, business value, and you're reducing the impact of risk. You have a develop phase, and this is where your data scientists and your ML engineers will likely collaborate to make an inference pipeline that is super robust. You'll have a package phase, and that's dedicated to ensuring that your deployed environment, your production environment, is the same as your dev environment. So that's making sure everything's properly versioned. You'll have a deploy phase, and that deploy phase is the biggest, broadest one. And this is all around taking that model and that inference pipeline and deploying that for use. And then finally, you've got your monitor stage. So the work doesn't stop. Like I said, the data is constantly evolving. So you're going to want to monitor that data and the model for performance and accuracy.
Okay, so many of you essentially have come across this diagram before. It may even just look familiar to you. And what this actually is the DevOps stream. It's the magical figure of 8 where you've got that constant flow. So you're coding, you're building, you're testing, you're releasing, you're deploying, operation, monitor, plan, and back to coding again. And when we look at these diagrams side by side, you can see a lot of similarities between them. The biggest one being is that you've got a constant flow. So we've got that constant improvement, that constant flow, constant monitoring of what we're putting out there in production. And that's really key to remember, is that the goal is the same. It's just that the underlying process underneath and what we actually need to put as priorities is slightly different, but essentially the goal is the same, is that constant deployment, constant improvement.
So if we dive in a little bit further into those actual life cycles, like I said, this is pretty important to your MLOps platform. So first you have your explore phase, and this is where your team of data scientists are going to experiment with models, algorithms, parameters, and features. At this stage, MLOps is primarily responsible for supplying those data scientists with the environment that they need to achieve this. So there's a whole heap of tools that you can leverage for this, and we'll cover some of them later on. But things like feature stores, which are a tool for storing commonly used features, so you're not replicating complex logic, and model experiment tracking tools such as MLFLOW, which we'll also cover later. Finally, building up a collaborative workspace for your data scientists to work is really important as well. You want them to be able to work and edit each other's code without having to leverage Git. So once your model has survived the explore stage, you will fall into the evaluate stage. And this is like a testing phase for evaluating your model for business value, accuracy, and ethics. So you'll want to test for business value first, and that will be things like making sure that it's solving the problem that you need it to solve, and it's not just there because it's cool. You want to test, discuss what the business requirements are that will kind of drive your decisions for the rest of the MLOps platform. Those things will be, say you've got a book recommender model. Do you want that to run every week and send out an email with book recommendations, in which case a batch model would be perfect? Or do you want a button on your website that will automatically recommend books on the fly, in which case you'll probably want something a bit more real-time scoring. So those things will affect how you deploy your model in the future. There are other things that you also want to test your model for, and these are things for compliance. So you want to make sure that your model is really interpretable, so you know the reasons why your model is making the decisions it is. And doing this, you can leverage libraries such as Interpret ML or SHAP, or you want to test your model for fairness. Like I said, you don't want to be discriminating against end users. And for things like this, you can use the AI responsible dashboard coming out from Microsoft, or you can leverage libraries such as Fairlearn. You may alternate between the explore and evaluate phases quite rapidly. You'll want to keep repeatedly testing your models, so it may be a few times before you can promote your model to the next phase of MLOps. And this next phase is the development phase. And so this is around building your robustness into the model inference pipeline. So taking your notebooks and your work from training to scoring. So data scientists typically won't have the background in order to deploy models effectively. So this will be something between your data scientists and your ML and DevOps engineers. And this will involve things like tools we've already seen before, such as Feature Store and MLFLOW, and model versioning. And it's really responsible for creating that robust pipeline. So when your model is in production, new categories or malicious attempts won't bring that model offline. Next, we have a package phase, which is quite a small phase, and this is around making sure that your deployment or production environment mirrors that of the environment that it was developed in. So you're versioning your libraries, you're versioning your models, and making sure that the deployment phase is super smooth. And so, like I said earlier, the deployment phase is probably the broadest phase. So MLOps is, and this is what most people think that MLOps is just deploying the models. And it's responsible for deploying models, yes, and it needs to make sure that the model complexity, size, and all those things that we discussed in the evaluate stage are considered. So if you've got your book recommender model batch scoring, you might keep that scoring in DataBricks and just running that once a week. Or you might want to deploy your model, for example, using Fast API, hosting it in Kubernetes for that real-time scoring. And then the final one of your MLOps lifecycle is the monitor phase. A very important phase. Your work doesn't stop once you've deployed that model. As I said before, the data is consistently changing. So you really want to make sure that your models are accessible and they're accurate. So you want to track for drift. And you may want to take it even further and say that if it's drifted and it's gone over a certain threshold, you want to trigger that automatic retraining. Retraining your model might fix the problem and it might become accurate again, or you might need to create a new model entirely. And in this case, you're returning right back to that explore phase.
Okay, so why data science is not like any other software project? There's often this misconception that with models, you just need to deploy them, right, and put them out there in production and everything's fine. Well, no, when it comes to working with machine learning models, essentially, there's a lot more to it, and we have to constantly nurture them and monitor them. And if you look at this diagram here, essentially, we've got the process there where we're going from business understanding to data understanding to data preparation, modeling, evaluate, deployment, and we're constantly going around in that circle again. As we saw in the previous diagrams, it's a constant flow, and we're constantly going through that process over and over again. Data is always changing, and so therefore this process is never done. We are always monitoring the model over and over again and making sure it is performing as it should do. So so just going into this with a little bit more depth here, essentially breaking it apart so we can see that in production we have evaluation, retraining, monitoring again over and over again that you have to do when you're working with models, which is where it's different from software, where software you put it out there in the wilderness and you monitor the logs and make sure you don't have any bugs. With a model, it's a lot more of a living thing with constantly changing data that you have to be constantly monitoring and running processes against to actually make sure that it is performing as it should do. Essentially, it has a complex life cycle, and it's just not always recognized essentially with models that you have to put that much more work and more process into actually getting them not just into production, but actually monitored and understood.
So what tools can you leverage for your MLOps platform? So one thing that we'll be covering quite significantly is DataBricks. So for those that aren't familiar with Databricks, it's really, you can boil it down to notebooks running over the Spark engine, which will allow you to run code really quick. And that's what it was designed for. But actually, it's really trying to break into that data science space, and it has a huge heap of reasons why you would use it for these reasons. So one would be that it supports R and Python, which are both very popular machine learning languages. And if you use the machine learning persona in Databricks, you also have access to loads of powerful machine learning libraries that are pre-installed on your cluster for you. Databricks also offers AutoML, so that is where you can upload your code and it will automatically generate you a bunch of models, however many you want to specify, and it will pick the most performant one and will actually allow you to drill down in the code for those. It offers feature store as well, which we'll be covering really shortly. They also offer cost-effective endpoints, so you can host your model both batch and now you can host them real time. You've also got that collaboration functionality, which is super important for the explore phase, that you allow your data scientists to collaborate on notebooks. There are Git integrations, so you don't have to worry about losing your code. And finally, there's a fully managed version of MLFLOW, which is super useful, and we'll cover that later too. So I'll cover some feature store now. So before I start, what is a feature? Thank you. So a feature is essentially a designed column in your data set. So you'll read in your raw data to train your model. And a feature will be a column that you've edited in some way that you'll then put into your model that will provide value for your scoring. And these can get quite complex. You can have something really simple, like in this case, just the number of sales per day, or you could have a really complex piece of business logic, which is quite specific. And you don't want to keep repeating that again and again, because you're just increasing your chance of error. And you want to consistently calculate this across your business. You don't want different departments calculating this feature differently. So using a feature store and uploading your features to a feature store for use will really reduce that risk. It also comes with a really cool benefit of that data scientists can then look into the feature store and they can see features that they can create with their current data that they've not considered before. And that might actually make a really big effect in their model. So there are a lot of tools that you can use for feature store. There are specific ones like Feast, which is an open source feature store, or there are some that are part of a larger solution, such as Databricks, and we'll be drilling into Databricks just now. So I will start with a demo. Cool. Right, I hope everyone can see. So I'm going to cover how you would use the Databricks feature store and why you would use it. So before I start using feature store in Databricks, it's super important that you select the machine learning persona. If I'm outside of the machine learning persona, none of these tabs or options are available. And the second thing to consider is that you're using an ML runtime Databricks cluster. So here we've got DBR 1.11.2 ML. That means I'm using a machine learning runtime. And that just ensures that the feature store library is pre-installed and you don't have to install it. So what I'm going to cover in this demo is that we're going to read in some raw data. We're going to create some features, and these features are going to be around pickup data for taxis and drop-off data. And we're going to store those into separate feature store tables. And then we're going to use those to score our model. So first of all, we want to read in our raw data, and I'm reading this in from a Databricks dataset, which is pre-installed or is available with every edition of Databricks. So it's a free-to-use dataset, and this is the New York taxi dataset. And as you can see here, it provides a bit of detail around the pickup time and the drop-off time, some distance, and how much the taxi fare cost. And what we're going to do is we're going to create some features that will allow us to predict what the fare amount is for future taxi trips. So we'll start off by creating our feature tables. So I've just got some helper functions here that will allow my code downstream to run. And then here we have a bit of complex logic in order to calculate different pickup features. And I won't jump into these too much, but it's important to know that this can be as easy or as complicated as you like. And the point of feature store is to make this replicated logic super easy to implement in your model. So here we have a function for our pickup features, and we have a function for our drop-off features. In my next cell, I want to actually run those functions. So I'll pass in my raw data, and it will calculate for these certain times those pickup features, and the same for the drop-off. So now I have two tables with the features that I want to include in my model. And we can see one of these here, that we're using our zip and our timestamp from our original data set, and it's calculated the mean fare window and the count trips window. So now we want to put these into our feature store for use later. So we can create a database, and you can see that here in my data tab. I've got my feature store taxi example, and then I want to establish that feature store. And then I want to create my tables. So here I'm using the feature store functionality create table, and I want to store it in that database I just created, and I want this one to be pickup features. My primary keys are the zip and timestamp, and that's what I'll be joining on. The data frame is going to be based on, so the contents is going to be based on that pickup features table. And I'm going to partition on the year and month to make things a little bit quicker. And I'll do the same for the drop-off features. So when you want to populate those tables, you just need to run the feature store write table command. Just here, I've just recalculated those tables using the functions earlier. So I'll write to these tables by providing the table name, providing the data frame, and I can do merge or overwrite. And I've done the same for the drop-off features. One really cool thing about feature store is then you can then just query them like a normal table as they're stored in Hive here. But because we've used the feature store functionality, we can actually also explore that with those features using the feature store tab. So here, if I jump into one of the features I've created, so this is my pickup features, you can see I originally created it a little while ago, and I last wrote into it today. And I can see, well, this is the notebook that I created those features in. So if I was exploring these features on a different model, I can see exactly what the logic behind those features were. And then there's actually a breakdown on the features themselves. So I can see that this one's an int type and this one's a float. You can also, from this tab, you can see if I've linked any online stores for scoring, but I haven't in this example. So how do I use this feature store to train a model? So I've set up a separate notebook here. I've still got my same helper functions. And to show you how I don't need to do any of that complex logic, I've read in that raw data. So this is how it looked before I calculated my features. I've imported my feature libraries. I've established that feature store. And here I am defining my lookups. So you can see I'm using the feature store feature lookup functionality. I can supply the table name, supply the features that I want to pull down, and I can provide what I'm joining on, which is the zip and the date time. And I've done the same for drop off. So now I want to use those to create a training set. So I've introduced MLFLOW here, and I'll cover that a little bit more in a sec. But I basically started an experiment. I've excluded some columns because this ends up overfitting the data. And then here I'm using feature store to create a training set. So what I've done is passing into this create training set function, I passed in my raw taxi data. I passed in the two joins to the feature tables that I want. I've established what I want my label to be, so what I'm actually predicting, and I'm excluding my columns. And then I'm just loading that into training DF. And if you can see, I've popped it out here. And you can see that I've created a brand new data set with those features without actually having to do any of the calculations in this notebook. And this is what it looks like. So now I want to use that to train my model. So I establish my columns, and I'm going to convert those to pandas so I can run it through a light GBM model. I won't dive into this too much, but I've done the typical test train splits. I've auto-logged my model, which I'll cover again in just a sec. Established those test and train data sets. I've passed in some parameters, and I've just trained my notebook on that training data set that I've just created. And then as I scroll down, I can log that model into the feature store, just here, passing in that training data set. So within feature store, I can see exactly what model it's used for. And then I can use this for scoring. So again, I'm reading in that raw data without the features. I'm passing in the columns that I want to score my model on. I'm picking up that model that I've just trained, and I'm scoring it by passing in my model location and that training data, that scoring data that I've just created. And in the back end, that will do all of the logic and all of the joins that I've set up. And then we can see our predictions. So here we've got our predicted amount and our normal amount. And luckily, they're quite close. And that's our model scored. So if I jump back quickly into the presentation, I'll just talk briefly about MLFLOW before I pass you to Anna. And MLFLOW is a super cool tool designed for tracking models through their experimental phase. So it really features in that explore phase of our ML lifecycle. So this will allow data scientists to automatically track models, parameters, metrics, and artifacts. And one awesome, really cool part of MLFLOW is it will also log that model for you to use later. So you can use in your inference pipeline, you can reference that model and it will automatically pull it down for MLFLOW, and it will pull down that latest version. And another quite cool thing that I'll show you as well is that you can also host your models through MLFLOW and DataBRICKS. So I'll jump back into that notebook where I just skipped over some MLFLOW stuff, and I'll just talk about how you use it. So if I scroll a little bit further up to where I first mentioned MLFLOW. So what I've done is I've ended the run just in case this notebook gets interrupted. And I've started a new run, and what that will do is it will start a brand new experiment for me. And I've created all my data set. And then as I come down here, I've actually used MLFLOW. I specified what model I want because MLFLOW has the ability to log specific models around different libraries like scikit-learn and H2O. Any data sciencey model, MLFLOW will normally have something that corresponds to it. And then I can run this auto log, so I don't have to specify what stuff I want to log. So when I run this train command, what it does is it will log all of the parameters that I specified here. So it will log the number of leaves, it will log what the objective is, and it will log what metric I want to use to test it. And as I scroll down, I can end my experiment towards the end, and I can save that model for inference. So in this location I've specified here, I can actually save that so I can use that model locally if I want to. So when I said that DataBRICKS has its own kind of flavor of MLFLOW, you can kind of see that in these tabs here. So if I jump into experiments, you can see I can go into my use feature store experiment, and you can see when I last run it, which was 39 minutes ago, and I can jump into that and it's automatically tracked all of those parameters for me. So if I was training, say, 100 models to test which one was better, I can very easily go in and see, find the one that's most accurate and see exactly what the breakdown is that made it that accurate. And if I was running a testing and scoring script, then my metrics would automatically have been logged here. And then if we scroll a bit further down, we can also see all the artifacts related to that model. So I can actually see this is the model itself, and it will provide you some code that you can download and you can score with your model locally if you want to. And then the final thing is that you can host these models. So here I've got that model that I trained, taxi example. It's on version 6 because I've done this experiment 6 times. And I can jump in and I can actually use this model for inference. So if I go into serving and I enable serving, I can click use model for inference and I can set up that scoring within DataBRICKS, which is pretty cool. So it gets you that deploy stage really quickly. But I won't do that now because I will pass you to Anna. Oh, wait, sorry. I mentioned model registries. Model registries, MLFLOW is one of them, and that's just somewhere to store your model. There are quite a few other tools that will do this. Anna might cover Machine Learning Studio, but Machine Learning Studio, similar to AutoML, will generate you loads of models and will allow you to store those models and then deploy them. And that's part of the package stage. Now to Anna.
Okay, so testing. Now, essentially, A/B testing is a concept that has been around for quite a while. It's not new, but we are now adopting it when it comes to actually testing our models. So what that essentially means is that when we have our existing model out there in production, we can come along with what we call a challenger model and actually have them both out there and have either all traffic going to both, or we could have the traffic split 50-50, so half traffic going to the existing model, half traffic going to the challenger model. And then essentially we can actually compare the two. So that challenger model at this stage, we can actually decide whether that challenger model should then become the current existing model, that our main model that we're working with, or whether we actually decide essentially that it's not good enough, whether that's down to how it's scoring, the actual speed. We can analyze it there, do those comparisons, and actually be able to, in kind of real time, be able to actually see what's going on and make sure that what we're about to overwrite for the existing model is actually good enough. And that's really key, because often when it comes to putting models out in production, often the existing one will get overwritten with a new one, and then you'll find that the new one isn't so great, and it can be really problematic. Even if you're able to roll back, essentially the damage could already have been done. So this is a really, really useful model. Like I said, been around for quite a while, and now we're starting to adopt it essentially when it comes to MLOps and testing our models. And that is part of the explore and the deploy phase.
So a brief little bit on model drift and decay. So I mentioned before that monitoring your model is super important, because you don't want your accuracy to reduce and you don't want to lose trust in your models. So a brief little overview of model drift. There are 4 distinguished types. So we've got feature drift, which is those input variables. So your input data, when that changes, that's called feature drift. And one example, if we go back to our book recommender, is if the books that are being sold are a bit different to what you've trained the model on. Label drift, which is when the model begins predicting new values. So if your book recommender starts predicting a higher rate of non-fiction, then that will be called label drift. You'll have prediction drift, which is when the true value drifts. And that might be that people start buying more and more fantasy books, and you've noticed your model is not recommending those, so that would be prediction drift. And then finally you have concept drift, and this is when the underlying concept behind the model has changed. So this could be if your bookshop starts selling like cakes, so you'd need a completely new model for that. So because of these different types of drifts, you don't want your model to completely lose accuracy. So you want to keep monitoring, and that is a really vital part of your ML workflow. I'm going to disappear off screen just a sec, sorry. Anna.
Okay, so architectures. Now, as data professionals, essentially, we are going to come across architectures such as like the Lambda architecture, and now we're getting told to use data meshes, and now we're thinking, well, do we still use a data lake? Do we go to a data mesh? And there's all these buzzwords flying around, right? And it can get really, really confusing. And there essentially is becoming this kind of question mark around MLOps. Is there a magical architecture that we could work with essentially with MLOps? And a good example when it comes to architectures, if we dip into the software engineering world, is because I've been doing this a long time. When I first started coding, it was very much a spaghetti approach. So it was very much interweaving the code into the HTML using classic ASP. And then we had a lasagna approach, which was having your web front end, your business layer, and then your data connection layer. So 3 different services there, but they were both very monolithic, and now we're all being told to use microservices. So kind of over this last 16 years, and there's more 4 architectures in there. Those are just some of the key examples. Over the last 16 years, it's constantly changing, constantly evolving. Microservices are awesome, they are great. But for MLOps, do we have this same approach? Is there a magical architecture that we should be following? And essentially, I don't want to be a consultant about this, but essentially, I'm going to say it depends, because it really does depend. And I'm going to give you this example. So essentially, the Rendezvous architecture came out of a book in 2017 by Ted Dunning and Ellen Friedman. And essentially, the Rendezvous architecture became very popular quite quickly. There was a lot of movement behind it. And it was looking to be, the golden ticket, the answer to actually what architecture should we be using. And very top level with the Rendezvous architecture, you have requests, so input data as a stream. You'll have lots of models out there at the same time. So this is roughly, again, with the A/B testing, you have different models that we pitch against each other. And then we score it as a stream. Run it through the rendezvous process, and then we get our response, and that's the very top level diagram of how it works. And even at this level, it could be a little bit confusing. Essentially, if say for data scientists, it's not necessarily within their realms. And if we expand that architecture a little bit further, the full rendezvous architecture, I fully expect people to look at this and be, well, what's all of this? What's all this going on? Do I need to understand all of this? Just focus here mostly on the fact that we have these 3 models. We have our main model, our canary model, our DECAY model, again, A/B testing. But we've got all of this going on around it, right? The message consumer, message producer, and that's just, say, if you're working with a message bus, say something like Kafka. Essentially, you've got all these messages coming in, you're processing them, you're sending them out to different models. This isn't really within data science realms, and it really needs like a data engineer, software engineer, data ops engineers, essentially, to get all this set up. And the big question is, do you actually need this to get your models into production? And the answer is no, you don't. What you really need to focus on is those 6 key areas that we've already highlighted, essentially how to achieve those in the best and most efficient way, especially when it comes to your proof of concept, your minimum viable product. You don't have to do, say, like a full rendezvous or follow another architecture. You just need to make sure that you're ticking those boxes to be able to deploy and monitor your model efficiently. And essentially, then we move on to the actual technology that you're going to work with. So, okay, so we're not going to go full rendezvous, but what tech are we going to work with within Azure? And we've got this EK system, aka the data science octopus from our own company, Advancing Analytics. This is our own diagram. And this has got loads of tech on there. And again, it's like really confusing, like which ones should we actually work with? Which ones are the best ones to work with? And I really don't want to say, but again, it does depend, and it depends on your team, your skill set, and what your kind of timescales are, and essentially what that ultimate goal is. And so what I'm going to move on to now, rather than giving you recommendations of technologies of what to use, because it is going to depend on your environment, I'm going to give you a real world example. So this is taken from our day job, myself and Tori, essentially a company that we work with, an insurance company, where we set up some MLOps, so got a model into production that was going to do some fraud detection. And this is really simplistic. It's only using like 4 or 5 technologies. So we're using MLFLOW, as Tori mentioned before. So that is essentially within DataBricks, but it doesn't have to be, but it sits on top of Kubernetes. And then we're working with Fast API. Now, Fast API, for those who don't know, is a package, a Python package, which enables you to have essentially a REST API. So it's used for lots of different purposes, but for us, we're wrapping it around essentially our model so we can get it into production. And then we wanted a data store, and we went with Cosmos DB, and we need that data store. So every time our models are scoring, we are able to push that data into a data store, and then we can use that on a later date. And essentially what we do with it is in DataBricks, we have a notebook that monitors drift detection. So what that will do is it will take the scores, say for the last 3 months, and it will check that our scoring essentially is on track and make sure that we haven't got any drift. So essentially the model is performing as well as it can do. And that can quite often happen because, as we mentioned, data is constantly evolving, it's constantly changing. So the model may not have changed, but the data will have. And we run that notebook once a week. Essentially, we're able to kind of give those results to different people in the team, so not necessarily the data scientists. And we were able to, as a team, able to actually monitor that model and make sure that we are happy, then that we have visibility with that model, and we are essentially happy that it's working as it should do. And that is all part of the 6 steps that we've already mentioned. So the explore, evaluate, develop, package, deploy, monitor. So we've covered all of those steps with those few technologies, haven't had to go for a rendezvous, and we've got it out there in production. It's handling loads of data, and we haven't had to go crazy with it. We haven't had to use a whole list of technologies. This essentially does the job, and that is really key when you're getting on board with MLOps, is using the technologies that work for you and just not going kind of over-engineering it for the sake of doing it, thinking that's going to make your life easier, when in fact it could make your life a lot harder. And again, those 6 steps again going round in that circle. Okay, so we are essentially here to talk about Azure and MLOps in Azure. So we're now going to move on to the Azure AI portfolio. So we've already covered Databricks. We've talked a little bit around Fast API, essentially that we could run in Kubernetes, and that would be in AKS in Azure. But now we want to look at what Azure actually offers as a solution. So this is a diagram taken directly from Microsoft. So this is their diagram. And on one side, we can see our data sources, so whether that's structured or unstructured, just essentially the different technologies we can work with. On the other side, we've got our business apps and our analytics. And in the middle there, we can see essentially within Azure ML, the studio experience and comprehensive MLOps, and essentially kind of like different areas that we can work with, technologies we can work with, sitting there in the middle. What's key there underneath, we have prepare data, build and train, deploy, manage and monitor. That is Microsoft's interpretation of what we've been talking to you about, those 6 steps. It's slightly shorter, so it's only 4, but essentially the concept and the end goal is exactly the same. Now, Build in May this year, so Microsoft Build, essentially they announced the Responsible AI dashboard, and this is part of the Azure ML Studio. And the Responsible AI dashboard, essentially, it's essentially a dashboard that enables kind of data scientists and other developers to easily implement responsible AI. So what it's doing is within a few clicks, you're able to have a dashboard on top of your model that's actually telling you if you've got kind of model drift or bias or anything like that going on really easily. And it's not just open to data scientists, it's open to others as well. And essentially it allows you to present that information to your stakeholders, to the people in the company that you want to be able to show that you have this visibility and this understanding, and it's all in a very aesthetically pleasing diagrams, essentially, that you can then illustrate to them and make sure that everyone's on board and everyone's happy, and it essentially gives you that monitoring that we need out of those 6 steps. Now, we're going to move on to blue-green deployment again, and the reason we're going to do that is because at Build in May, as well as the Responsible AI dashboard as part of ML Studio, they also announced managed endpoints. Now, managed endpoints essentially are REST API endpoints that wrap around your models. So like we illustrated before with Fast API, when we talked about a real-world solution, this is essentially a REST API that you get out of the box within a few clicks. So if you're working in ML Studio, you've got your model there. Within a few clicks, you are able to wrap a REST API around it, and then actually the real powerful part is actually this blue-green deployment. So I've got different deployments there with different traffic allocations. So I've got 50-50. And essentially you can then start testing straight away. So you don't have to be like a full programmer. You can literally get this set up and get the testing going kind of off the bat really, really quickly. And essentially that's really powerful and really useful. And that's part of essentially the deploy stage. Now, before we move on to a demo, because I am going to show you ML Studio, I just want to mention that essentially we also have the CLI, SDK and REST APIs. So there is the Python SDK v2 in preview, and it simplifies the developer experience. So if you are a programmer, if you are a Python programmer, there is the Python SDK that you can work with hand in hand with ML Studio. And it is essentially a lot better than the v1. And there's lots of tooling in there for you to work with when it comes to working with your models and working with MLOps. And then secondly, the command line interface v2 is generally available and allows users to participate in machine learning life cycles without needing to learn specific programming languages. Now, again, MLOps is about everyone. It's not just about the programmers, the data scientists. Essentially, everyone should own it. And having the command line interface, which isn't just there for programmers, is really powerful, really useful, because essentially others in the team are able to get in there and actually start experimenting and playing and understanding what's going on. So all of those are worth looking into and playing around with. Okay, so we'll move to a demo. Right, so what we see here is essentially we are in ML Studio. So, for example, if I was to go to models here, I can see I've got some models already set up. I've got a diabetes models here, and then some of the models there that are set up by others within the team. And we have, for example, notebooks, so the same as we saw in DataBRICS, essentially, where Tori was working with notebooks. Exact same concept here, very similar to if you've worked with Jupyter notebooks. You can come in here and start building out your notebooks, and then you can start generating, say, pipelines within ML Studio. And that's something we're not covering in this talk, but I do encourage you to have a play around with this and do a little bit of learning if you're interested in kind of machine learning, essentially, and getting it into production. So what we are interested in at this stage in this demo is essentially our endpoints. So we've got endpoints here, and if I go to create, and I'm going to take you right through to the end, but I won't hit complete because it takes a long time to set up. But if we give this endpoint that we're going to create a name, I'm just going to call it test, not very imaginative. So I give it a name of test, I go to next, and it says, what model do you want to work with? So right, I'm going to click my diabetes data, and then I'm going to give my deployment a name. So this is where you can do like your blue-green A/B testing. You can give it a name accordingly if you want to. If we go to environment there, and then we can select essentially our compute under the hood. So if we were to deploy this and then discover that essentially it's not powerful enough, or that we're not actually using it all and we're paying too much for a model that isn't actually using all the compute, we could do a new deployment against the same model and actually change the compute under the hood. And there was just straight, yeah. So just to illustrate here, sorry, the compute type, we're going for managed because this is a managed endpoint. Please note that you can also do, and this has been around for a while, an actual Kubernetes compute type, and that would essentially be your own Kubernetes cluster. So even if you started off with a managed endpoint, you could switch to your own cluster if you wanted that control essentially further down the line. Which is really, really powerful, really useful. And because we're working with a REST API, it's easy to switch that out essentially in your code if you were to change it essentially and do a new deployment. So we're selecting our diabetes data. We can click through all of our steps. We don't need selection environment because it's managed. And then we select essentially our compute. Now, again, I'm not going to do this here because it takes a long time. I'm going to go to the one I made earlier called demo, not very imaginative. And essentially, this is our endpoint. This is our endpoint against the diabetes dataset and the diabetes model. We can see our blue and default deployments. I can add a deployment here, so I could create another one and change the traffic essentially. So I could deactivate one and then just have another one come along and take 50% of the traffic if I wanted to. I could split it 3 ways. Essentially, however you want to work it so that you're able to test your different versions of your model or test it against different compute. useful to see here. It gives you your REST endpoint that you can work with. It gives you a Swagger URL. So anyone who knows what Swagger is, essentially that's a really cool feature when it comes to REST APIs. And then if you look at this ribbon at the top here, if we go to test, essentially we can actually start throwing data in here. So we've created an endpoint without having to write any code, and I can start throwing data in, and it will essentially give me some results. So what I will do.
Just a quick warning, the 15 minutes warning.
Thank you very much. Okay, so if I just grab some of that example data, which I'll show you in Visual Studio Code as well. If I throw this data in, hit test, it starts giving me results. So straight away I can start actually working with this endpoint and start fiddling with it without having to do any sort of coding, and I can test against different deployments to actually see if those deployments are giving me the same results. And I don't have to be an expert in data science to do this. I'm a data engineer, but this is super useful. And if I start seeing any problems, I can go to someone like Tori and say, I'm not sure this is working as it should be. And then we go to consume. And now again is our REST endpoint. And here, this is really powerful. We've got some snippets of code to get us started. So we've got C#, Python, and R. So we can grab this code, start working with it, and it's just copy and paste and start adding it into our solutions. That is super powerful, super useful. Don't have to use those 3 programming languages. This is a REST API. You can consume it however you wish, but it's nice to have those 3 common languages essentially there for you to get going. And now if we go to the monitoring tab, now for those who have worked with Log Analytics and Azure Monitor, this is hooking directly into all of that, into that Azure ecosystem. And essentially it's giving us those logs, it's giving us those metrics. And what we can see here, essentially we've got the blue deploy and default deploy there. So we can actually immediately pitch them against each other and say, right, this one's performing better than this one. And I'm doing this from a REST API perspective, so from a software engineer, from a data engineering perspective. Is this REST API, as a REST API, working as it should do? Am I getting the speeds, the responses that I am expecting? So this would work hand in hand, say, with the Responsible AI dashboard, which you can set up within Azure ML Studio. So within the model, you can set all of that up. And then you can work with all of this tooling out of the box and actually get those visible results there for you to actually monitor and feel comfortable that your model's doing what it should do. So if we go to, this is Visual Studio Code. I've took some of that, one of those snippets of code for the Python and copied and pasted it into here. So I'm not going to claim that I wrote all of this, that it gave me most of it that I needed. And I've thrown in some demo data. And then I'm literally straight away able to start essentially hitting run, and it starts giving me those predictions for that data, right? This is super powerful when it comes to, say, doing testing. So doing integration testing, end-to-end testing. As a data engineer, as a software engineer working with the data scientists, I can actually start setting all of that up around this and making sure that those models are performing as I expect, not just from a model perspective, but from a software engineering, data engineering perspective. So if we're trying to meet SLAs for the company, then we can make sure that that is happening here and make sure that we have those integration end-to-end tests, that the performance is essentially as it should be, and that the code is running correctly and we're not getting 500 errors from the REST API. We can do all of that now, just essentially from grabbing this bit of code and starting to build on it and weave it into our solutions, essentially. And what is also key is in these headers here, I've commented out this bit at the end, but if I had this in my headers, this is pointing to the default deployment. I could set that to, say, like my blue deployment, whatever deployment I've got out there, and actually have this running against a specific deployment. At the moment, it's just because the traffic is 50-50, like a load balancer, it is just picking one each time I hit it. But I can specifically test deployments. And again, that comes down to end-to-end and integration testing. So we're working hand in hand with data scientists, DevOps engineers, data engineers, software engineers, all able to work together to actually get this model into production and monitored and understood as it should be. So we'll go back to slide deck. Okay, so that essentially summarises our session. Okay. So that essentially summarises our session. Thanks everybody for joining. We want to say special thanks out to we're going to say Tori, she's here, and Tori's awesome. I work closely with Tori on projects. Essentially, she's the brains behind the data science. But then I also want to thank Jan and Terry there. Terry's our director, and essentially they've put lots of work out there, like the blogs and videos and things that you'll be able to look up if you're interested. And finally, we have some links here. So these are some useful links, some blogs. There's a video on there. So worth noting down if you want to get a little bit further with MLOps based on what we've shown you today. There's some details on the rendezvous architecture. There's a video that goes into more depth on the diabetes data that I was showing you. So lots of stuff there to get you going. Tori, anything you want to add?
No, thank you for watching.